sharing my screen with you. This is the screen. So this is our 7th lecture, that is of week 7. As you know that we have studied lecture and lecture 6 of week 6 about the non-homogeneous differential equation. So we have studied a method which is called undetermined coefficient method. So in this method, we have studied that how to find the particular solution for a non-homogeneous differential equation. Now, there are some restriction in this method. The domain of this method is not very large because when at the right hand side there is only constant function, there are polynomials, there are exponential function, and there are trigonometric, that is sine and cos function, or the addition of these functions, or the multiplication of these functions. So you are able to select particular solution. Otherwise, you are not able to select particular solution if at the right hand side functions are other than these functions. So if at the right hand side there is log x, there is sine inverse x, there is e power sine x, there is 1 over x suppose, so you are not able to select yp. So therefore we need to study another method for finding particular solution. समझ में आ रहा है ना?
Yes, sir.
Okay. So the contents of this lecture is method of variation of parameter. This method is also for finding the particular solution for a non-homogeneous differential equation. So इसको थोड़ा सा आगे हम स्टडी कर रहे हैं. What are initial value problem? What is boundary value problem? We have already studied this, but we will study it in second order differential equation. We have also used some models, some linear equations, and we will solve these linear equations. So first of all, method of variation of parameter. This method is for finding the particular solution for a non-homogeneous differential equation. As I told you that this method is more general method to solve the non-homogeneous linear differential equation. This method can be applied to differential equation where the method of undetermined coefficient fail. If you have a right hand side, if you have log of x at the right hand side, so you know that the undetermined coefficient method which we have studied previously in previous lecture, that fails to select yp. So the method of variation used where the method of undetermined coefficient fail. So this method is not limited. जैसे मैंने पहले कहा, this method is not limited to the input functions, that is combination of 4 type of functions: constant, polynomial, exponential, and trigonometric. So this method is not limited only for these functions. You can take another function, that is tangent inverse x, tangent x, cotangent x, e power sine x, e power x square. So there are many functions it exists at the right hand side. So you can find this particular solution by using this method. So actually this method is not limited only to constant function, polynomial, exponential, and trigonometric. So ये limited method नहीं है सिर्फ खास टाइप के फंक्शंस के लिए. समझ आ रहा है ना? जी.
Yes, sir.
Okay. It is also applicable to linear differential equation with variable coefficients. So if the coefficient of a differential equations are variable, you can also use the method of variation of parameters for finding the particular solution. So the last point, note this point, however, the particular integral yp, जिसको हम कहते हैं, is only possible if the associated homogeneous equation can be solved. If you have a non-homogeneous differential equation, suppose, and if you can able to find the complementary solution yc, you will be able to find yp and the method of variation of parameter. You are not able to find particular solution using method of variation of parameter if you are not able to find yc. So it means that there is a connection between yc and yp in this method. If first step is, if you can find yc, then you will be able to find yp. So let's see कि आगे क्यों ये बात कर रहे हैं. So कुछ points note करें, note these points. First thing is this method is more general as compared to the previous method, because in previous method, if you have a certain type of specific type of functions at the right hand side, so you can use the undetermined coefficient method. That is previous one. In this case, if there is any function at the right hand side, you can deal with that function and you can find the particular solution by using the method of variation of parameter. This is one step. Another step is the this method can also be deals with when the differential equation is of variable coefficient. So this is another important thing. And third thing is the yp particular solution is connected with yc. If you can find yc using the method, if you can find the complementary solution, then you will be able to find yp using the method of variation of parameter. So I think this is simple things. This is general. These are general things. Now, important thing is now this one. इसको थोड़ा सा गौर से देख लें. This is important. So let's see. This is what y dash plus px into y dash px into uh, y equal to f of x. What is this? This is a non-homogeneous first order differential equation. This is non-homogeneous first order differential equation. What will be second order? It will be y double dash plus px y dash plus qxy is equal to f of x. You know about this. If you take y dash plus px into y, px means function of x, this is equal to 0. So this is homogeneous equation. This is what? This is non-homogeneous. This equation 1 and equation 2 is now homogeneous differential equation. So let's write equation 1 in this way. We can equation 2. We can write this equation 2 as dy divided by y is equal to minus p into px into dx. हम ऐसे लिख सकते हैं इसको. If you replace y dash by dy by dx and separate the variable, so you will get this one, dy by y is equal to minus px dx. So if you integrate it, you will get minus integral of p into dx. I am not writing now px into dx. P is a function depending on x. So p को ज़हन में रख ले, p is a function of x. So if you write this constant of integral is log of c1, yeah, c. So you can write this log of y. This is equal to if a function is not in the form of log, so you can write it log of e power that function. So this is log of e power minus px into dx. इसको ज़्यादा समझाने की ज़रूरत भी नहीं है, because you know about this. This is a first order differential equation and you can easily solve this. So this is log of y. This is equal to that is this is what this is c1. So this will become log of C1 e power minus p into dx. So this is log of y. What is y? If you take anti-log, so you will get y equal to c1 e power minus into integral of p into d of x. So if you take y, so this will become c1. So let's say this is y1, this function. This function is y1. This is a function. Say this is y1. So this is called YC because we are solving a homogeneous equation. So the solution is known as YC if you are solving a homogeneous equation. ये clear हुआ? Is it clear?
Yes, sir.
Okay जी. Now
ये y1 किस तरीके से किया
जी
y1 y1 इसका पहला सॉल्यूशन है
y1 इसका solution है e power minus px. If you put this e power minus p into dx and this equation 2, so this will satisfy this equation. Now let, according to this method, now I am starting the जैसे मैंने पहले कहा था, if you are able to find yc, then you will be able to find yb using the method of variation of parameter. Let yp is equal to u1 into y1. This is equation 3. Why we are selecting this and how we select this. This is yp means particular solution. Let yp is equal to u1 v1. This is according to the method of variation of parameter. You look into the yc. You only change the constant of integral by n unknown functions in yp. In this method, first you will find yc. After finding yc, you only change the constant of integral into unknown function u1. Suppose if you have a second order differential equation, so what will be yc for that second order differential equation? You know, j c1 y1 plus c2 y2. So this will be the complementary solution if your differential equation is of second order. If it is of third order, so there must be c3 y3. यहाँ तक समझ आ रहा है ना? So what is your yp in this case? Yp will be u1 y1 y1 plus u2 into y2. So this will be your yp. You only change the constant of integral. If there are two constant of integral, you replace it by two unknown function, u1 and u2. If there are three function, you change it into u1, u2, u3. If there is only one, so you replace it by u1. यहाँ तक तो क्लियर हुआ ना?
yes sir
अच्छा जी. Now take the derivative of this y dash p. So what will be y dash p? Y dash p will become, product rule use करें. This is u1 dash y1 plus what? u1 into y1 dash. So replace this value of y dash p and yp in equation number 1 instead of y dash and y. So as you replace the values of yp and y dash p in equation 1, so you will get this one. You will get this equation. It is you will get this equation. You will get this equation. देख लिया? This one. ये नजर आ रहा है?
Yes, sir.
अच्छा. When as you replace the values, and put it in the given equation, this one. So if you take common u1 from some term, so you will get this equation. This is simple one. As you put the values, you take common u1, so you will get this equation. Okay. Okay.
Yes, sir.
Okay, Ji. So put these two values in equation one and take common. U1 common. This is u1. This is u1. So these two will become common. So as you take common, so you will get this equation. Now let's see the coefficient of u1. This must be 0. 0 hoga, this must be 0. Or why? Because this is homogeneous equation. This is first order homogeneous equation. And y1 is the solution of this equation. So it means this must be 0. Okay.
पॉइंट रिपीट करो दोबारा.
Okay. So let I am putting the values. I am putting the values. What is y dash p? Put it in one. So this will become u1 dash y1 plus u1 y1 dash plus p into y1. Sorry, p into y. Y means u1 y1 and equal to what? Equal to f of x. यहाँ तक क्लियर है? Is it clear? Yeah. Yes. Is it clear? Is it clear now? This is equal to okay. This is equal to u1 dash y1. This is equal to f of x. So if you see it, the coefficient of u1 as y1 dash plus u1 y. So what is this equation? Equation 2 is y dash plus p into y equal to 0. Now this y1 is what? This y1 is actually the solution of equation 2. So if you put y1 instead of y, so this will become 0. So it means this coefficient is 0. This coefficient is 0 without y1. So this will become 0. So you only obtain this term. This term is du1 by dx, du1 by dx into y1, into y1. This is equal to f of x. So you will get this equation. This is simple one. You will get this one. And after this, if you integrate it, so this one, you will get what? You will get a du1 y1 du1 by dx equal to f of x. If you rearrange, this will give you du1 f of x. If you integrate it, you will get this one. So this is the value of u1. If you replace this value of u1, where? If you replace this value of u1 in this equation, and this equation 3, this is u1. So if you multiply u1 by y1, you will get particular solution. So if you are able to find u1, multiply it with y1 with the first solution, you will get particular solution. So this is simple. Let's move towards the second order to understand the second order differential equation. So this is simple one. This is first order differential equation, and first order you know about the solution of it. How to find the solution for a first order differential equation. Now let's move towards the second order. So what will be the solution of second order differential equation? Suppose so now what is this? This is a second order differential equation, y double dash plus px into y dash plus q of x into y. This will be equal to f of x. This is a non-homogeneous second order differential equation. So what we did for yc, what we did for yc, we take this equation equal to 0. Y double dash plus px into y dash. Actually, I am writing it px is only p, suppose, plus qx is q. So we remember that q is a function of x. So this is equal to, now this is equal to suppose q of y. This is equal to 0. So what will be the solution of equation 2? If you remember, the solution of equation 2 will be equal to yc will be equal to c1 y1 plus c2 into y2. If it is second order, so it will be the y complementary solution. So what will let, according to this method, let yp will be equal to what? u1, replace this c1 by unknown function u1, y1 plus c2, and this is equal to, oh sorry, this is not c2, no, this is u2. This is u2 into y2. Now the remaining calculation is for finding y1 and u1 and u2. How to find this u1 and u2? If you are able to find this u1 and u2, you multiply u1 with y1 and u2 with y2. So you will be able to find yp. If you are able to find yp, so you add it with yc, you will get the general solution. So how to find this u1 and u2? So take first derivative of y dash p. So y dash p will become, this will become u1 y1 dash. Apply the product rule. So plus this one is u1 dash into y1 plus this is u2 into y2 dash. This is plus u2 dash into, sorry, y2. Yes. This is y2. This is what? This is y2 dash. Now, the question is, remember this. One thing, if you are going to find u1 and u2, it means you are going to find two unknowns. ये समझ में आ रही है बात?
Yes, sir.
And why?
Yes, sir.
There are two unknown function u1 and u2. So let, I am taking let u1 dash y1 plus u2 dash y2. This is equal to 0. Let this is equal to 0. This addition of this term and this term is 0. Let, आप क्वेश्चन ना पूछे, ठीक है जी. Let this is 0. मैं आगे बताऊंगा why this is 0, why we are taking equal to 0. So at this stage, let this is equal to 0. So if this is equal to 0, so let's say this is equation number 3. Let's say this is equation number 3. So what will be y dash p? What will be y dash p if this is equal to 0? So y dash p will become u1 y1 dash plus what? Plus u2 y2 dash. This will become your y dash p. Is it clear?
Yes, sir.
What is your y
Yes,
double
sir.
dash? Okay, ji. So what is your y double dash p? So again take the derivative, but the derivative of these two terms. Now this is your y dash p. Now what is your y double dash p? So if you see this, this is your y double dash p. Okay, this is your y dash p. Let this is equal to 0. This one. So this is your new y dash p. So this is y double dash p. Is that okay? So take the double derivative of this function. You know how to take the derivative. Okay, ji. So putting these values, what are these values? This is yp. This one is your y dash p, and this one will be your y double dash p. So if you put these values in equation number one, so you will obtain this one, this one, this one. You take some, you take common u1 from some terms, you take common u2 from some terms, and write the remaining terms as it is. Okay, ji? Only putting the values of yp, y dash p, y double dash p, you will write this equation. Okay? Is that okay?
Yes, sir.
Okay, G. So let's see. What is y1? What is y1? Y1 is the solution of this homogeneous equation. If you see this homogeneous equation, this is your y1. This is your y1. Oh, sorry, this y1 is the solution of this equation. Hey, y1 is the solution of this equation. Y2 is also the solution of this equation too. So if y1 is the solution of this equation, so if you replace y by y1, so this will give you 0. If you replace y by y2, so this will give you 0. So it means that this is equal to 0. If you see y1 double dash px y1 qx y1 equal to 0, y2 double dash p y2 dash q y2 equal to 0. So it means the coefficient of u1 is the same. It must be 0. The coefficient of u2 must be 0. So if you take these two 0, you will get u1 dash y1 dash plus u2 dash y2 dash equal to f of x. This one, the second equation. Clear हुआ? Is it clear?
सर जब हम yp प्राइम yp डबल प्राइम की वैल्यूज को इक्वेशन 1 में पुट करेंगे तो हमें कौन सी इक्वेशन मिलेगी?
ये this one.
दिखाई नहीं दे रही, किस पर आप कर रहे हैं?
This one. You get this one. असल में ये इमेज बन चुका है. This one equation. अभी नजर आ रही है?
यस सर.
Yes, sir.
Okay, जी. Now the coefficient of u1 is this one. Coefficient of u1 is this one, so it must be 0. And coefficient of u2 must be 0. Because this is the same homogeneous equation. And y1 is the solution for that homogeneous equation. So it must be 0. Okay?
यस सर.
Okay, Ji. So you will get to u1 dash y1 dash plus u2 dash y2 dash. This is y2 dash equal to f of x. That is the second equation. इसमें से आप देख ले, this is the second equation. जो second equation इसमें से है नीचे जो second equation है इसमें ये वाला मिल जाएगा. u1 dash y1 dash plus u2 dash y2 dash is equal to f of x. नजर आ रहा है ना नीचे वाला equation?
यस सर.
Okay, Ji. So what is the first equation? This first equation is, we have let this is equal to 0, this one, this one. So on the basis of this equation, we derived another equation, which is this one, the second one. So when there is, when we apply the condition that is given in equation 1, this one, so you will obtain the second equation. So these two equations are actually connected with each other. It depends on each other. So this will become a system of equation. ये बात समझ में आ रही है?
No, sir.
देखिए, we obtain, if you put the value of yp, y dash p, y double dash p in equation 1, you will get this equation, you will get this equation, this one. Okay, u1 dash, y1 dash plus u2 dash, y2 dash equal to f of x. Is it okay?
Yes, sir.
So now this equation is derived on the basis of assumption. Now this equation is derived on the basis of assumption. Assumption was, we have did some assumption in y dash p, if you remember. We have taken that and y dash p, let the sum of these two terms is 0. समझ आ रहा है? जी, हमने ये assumption नहीं लिखा था कि let the sum of these two terms is 0.
Yes, sir.
So under this assumption, we actually find the new yp and then we differentiate the new yp and putting the values in equation 1, and we derived a second equation. So now the assumption and second equation derived from the non-homogeneous equation are connected with each other, because on this assumption, your next equation derived from equation 1, it depends on the previous equation. जी,
Okay, sir. Clear
okay.
हो गया.
Okay, G. So this, you will get this set of equation, that is u1 dash y1 plus u2 dash y2 equal to 0. This is actually our assumption that the sum of these two terms is 0. And the next equation is derived from non-homogeneous equation. So now this is a set of equation. Now this is a set of equation. This is a set of equation. So if you solve this set of equation, you will get u1 dash and u2 dash. This set of equation is unknown on two variables. One is u1 dash, because u1 dash involved in both equation. u2 dash involved in both equation. So it means this is a system of equation, system of differential equation, and this is dependent on u1 dash and u2 dash. So let's remind the Kramer rule. If you remember, if you have a system of equation a1x plus b1y is equal to c1, a2x plus b2y equal to c2. So how you write the value of x, if you remember? So you write the value of x is equal to what? You write the coefficient matrix determined at the denominator. याद है?
Yes, sir.
Okay, G. So if you have a system of equations, suppose this one, I'm writing it here. So so you will be able to solve, I think, the Kramer to use the Kramer rule. So it is simple, but I am taking a reminder about this a little bit. So if you have suppose if you have a system 2x plus 3y, suppose this is equal to, suppose 1. If this is a second equation, this is minus x, suppose this is minus x plus y, this is equal to, suppose, minus 1. Second equation. So what is the value of x? the value of x is actually W1 by W, and the value of y is actually equal to what? W2 by W, if you remember. What is W1 and what is W2? So
Rho.
G W1 is actually W is actually the determinant of the coefficient matrix. In this case, the coefficient matrix is 2 minus 1 3 into 1. This is W. So you will get a value, suppose this is equal to 5. What is W1? And W1 do not write the first column and which is in W. Instead of that column, you write the right hand side values, that is 1 and minus 1. And you write the second column same as in W. So this is 3, 1. So this is, you will get again, this is 4. What is W2? W2 is write the first column as it is in W. So 2 into minus 1. So instead of second column, write the right hand side values and you will get this is equal to, I think, minus 1. So now you divide these values, you will get the values of x and y. You remember this. Okay? Is it okay?
Yes, sir.
Okay. Okay, Ji. So if you have a equation of the form, this is u1 dash, y1 dash, this is suppose u1 dash, this is u1 dash, y1 dash, plus u2 dash, u2 dash, and y2 dash. This is equal to f of x. So if you have these two equations, that is, this is suppose equation 3 and 4. So how to find, now what is, here the variables are x and y, if you see. But here the variables are u1 dash and u2 dash. So what is the value of u1 dash in this case? What is the value of u1 dash? This is w1 by w. W1 by W. What is U2 dash? What is U2 dash? W2 by
W2 divided by
W2 by W. So what is W1 and what is W2? Sorry, what is W? W is what? बता दे मुझे. Y1, the coefficient of U1 dash is Y1. Coefficient of U2 dash, this is Y2. And the coefficient of U1 dash in next equation, this is Y1 dash. And this is Y2 dash. This is your W. What is your W1? कौन बता सकता है? 0 into f of x.
0 s of x. Yes, sir.
Y2 dash.
Y2 dash.
Yes. And this similarly you can write W2. W2 is equal to what? This will be Y1 dash, and this is 0 and f of x. So this is the values of, if you find these determinants, you put it in W1 by W, and you then integrate this value, so you will get U1. Is it clear? So let's start an example. Let's start an example to clear this thing. So we are taking an example. The example is so let's start an example. The example is, suppose,
Yes, sir.
okay. So summary of this method. In summary, you first write the homogeneous equation of that non-homogeneous equation. You find YC, then you find W, and then you find W1 and W2 in next step. Then you divide W1 by W2 by W, and then you integrate, you will get U1 and U2, and at the last step you put it in the YP, so you will get the solution. So these are the steps, these are simple one. Now this is example one, y double dash minus 4y dash. This is
सर सेकंड ऑर्डर नॉन होमोजेनियस डिफरेंशियल इक्वेशन ले लेना, सेकंड ऑर्डर लेना.
G second order non-homogeneous. So
वो वाली एग्जांपल कर रहे हैं, सेकंड ऑर्डर वाली.
इस मेथड से हम नॉन होमोजीनियस सॉल्व करते हैं ना.
ये सर मैं कह रहा हूँ कि जो एग्जांपल कर रहे हैं ना वो सेकंड ऑर्डर नॉन होमोजेनियस डिफरेंशियल इक्वेशन ले लें सर. सेकंड
वही लेंगे ना, वही लेंगे, क्योंकि हमने इस मेथड से तो नॉन होमोजीनियस को सॉल्व करना है. सो y double dash, this is y double dash minus 4y dash plus 4y, this is equal to x plus 1 e power 2x. Now if you see the right hand side term, so you can also solve this differential equation by using the method of undetermined coefficient method, because you are able to select yp. कर सकते हैं ना. You are able to select yp for this function. For yc, what is for yc? What we will do? For yc, we will take y double dash minus 4y dash plus 4y. This is equal to 0. So this will become 0. This is now homogeneous equation. For yc, we will make this equation as homogeneous and we solve. So what will be the solution of this? Its characteristic equation is what? What is the characteristic equation? Its characteristic equation will become m square
4m
minus
plus
4m
4.
plus 4 equal to 0. This will be its characteristic equation. Yes.
M square minus 4m plus
Yes.
4
Yes.
equal to 0.
Yes. So this is m is equal to 2 and 2. So what is your yc? If you remember, yc will become c1 e power 2x and plus c2 x e power 2x. Is it clear? Okay.
Yes sir.
What is your yp? This will be u1 e power 2x. So only replace c1 by u1 and c2 by u2 x e power 2x. This is your yp. What is your y1? As you find yc, so with product of c1, this is your y1. So y1 is e power 2x. What is your y2? x e power 2x. समझ आ रहा है? Is that clear? This is your y2. This is your y2. Is it clear?
Yes, sir. Clear.
Okay. So what is u1? What is u1? This is w1 by w integral.
Yes, sir.
Yes. What is u2? This is w2 by w integral. So, but you have only to find these three things. What is w1, w2, and w? So what is W? If you remember, W is the coefficient matrix. So Y1, Y2, Y1 dash, Y2 dash. This is your W. Or simply you can write, what is Y1? Y1 is actually e power 2x. What is your Y2? This is x e power 2x. What is your Y1 dash? Y1 dash is 2 e power 2x. What is your Y2 dash? This will become e power 2x plus 2x e power 2x. समझ आ रहे हैं ना? So this will become e power 4x. This become e power 4x. If you solve this, you will get e power 4x. Is it okay? G.
Yes, sir.
Okay, G. So what is your W1? This is your W. This is your W. This is your W1. W1 is what? W1. What is the formula for W1? 0 f of x. What is f of x? In this case, f of x is at the right hand side function as x plus 1 e power 2x. So 0 f of x, y2 dash is equal to this one. And what is W2? W2 second column may 0 into f of x. So you already know about this. So remember three things. For W1 and for W2, you need only three things. One is Y1, this one is Y2, this one, another is f of x, this one. So तीन चीजों की आपको जरूरत पड़ती है, Y1, Y2 and f of x. This is f of x, this one. So if you know these three things, so you are able to find W, W1, W2, and you are able to find to divide it and find the integral. So after finding this U1 and U2, you put it in the YP, you will get the general solution. Okay? G.
सर e power 4x
Okay, sir.
इस इक्वेशन में पुट करना है, w is equal to power 4x.
ये देखिए, this is the formula for W1. This is the formula for W2. So 0 is fixed. F of x is the right hand side function. If it is e power 2x, right f of x is e power 2x. If it is x plus 1 e power 2x, so write it this one. If it is log of x, so write log of x. So f of x may be any function. Y2 is the second solution, and y2 dash is the x derivative. What is W2? Y1 is the first solution, y1 dash is the x derivative, and 0 is the homogeneous side 0, and f of x is non-homogeneous side function. So I think this is simple.
Okay, sir.
So these are three formulas. What is W? W is y1, y2, y1 dash, y2 dash, and this is W1, W2. So this is example 1. So this is simple now. Now this is another example. Example 2. What will be its characteristic equation? YC क्या होगा? What will be its
4m minus 6 सामने करें ना इक्वेशन सर.
G. So I'm writing it here. This is what 4y square. Suppose this is what? This is 4y double dash plus 36y
4m square plus 36m
G equal to cosecant of
4m square plus 36m is equal to 0.
जी.
4m
So this is 4
4m square plus 36.
4y double dash plus 36y. This is equal to 0. So this will be 4m square plus 9. This will become plus 9. Sorry, plus 36 plus 36 equal to 0. So if you take common 4, so you will get m is equal to what? Plus minus 3 iota. M is what? Plus minus 3 iota. This is the value of m. So what is yc? What is your yc? G. Your yc is c1 cos of 3x. याद है? Plus what is c? This is sin 3x. Alpha is 0 in this case actually. So e power 0 is 1. याद है ना? Is it
Yes,
clear?
sir.
So what is yp? This is u1 cos of 3x. This is u2 sin of 3x. So what is your y1? कौन बता सकता है? What is your y1? It is cos 3x. What is your y2?
X into cos 3x. X into cos 3x.
G. What is your f of x?
Cosecant 3x.
Cosecant 3x. This is cosecant 3x. So this is your y1 actually. This is your y2. Like, and remember one point, you can also write c1 sin 3x and c2 cos 3x. So y1, y2 अगर replace हो भी जाए, there is no need to memorize this, that y1 will be this one and y2 will be this one. Maybe your y1 is sin 3x and y2 is cos 3x. If you write it, yc is equal to c1 sin 3x and c2 cos 3x. So याद हुआ ना? समझ आ रहे हैं जी?
Yes,
Sir.
Okay जी. So what is your w?
Sir.
What is your w? What is your w? W is y1. So you need only three things: y1, y2, and f of x. So you deal with these three and find w, w1, w2. What is y1? This is cos 3x. What is y2? This is sin 3x. And then take the derivative here and here, and you open this determinant. I think you will get 3. Okay? So similarly, find w1 and w2. So you will get this one. This is your w, which is 3. This is y1, this is y2, this is y1 dash, this is y2 dash. Now in step 4, what is your f of x? F of x is 1 over 4 cosecant 3x. So this is your w1, this is your w2. You then divide w1 by w. You will get and integrate it. You will get u1 and u2. So clear हुआ ना?
Yes, sir. Clear है.
Okay.
Yes, sir.
So similarly, this is example 3, example 4, example 3, example 4. Example 5, example 6, example 7, ये आप खुद कर लेंगे, ठीक है जी. Same procedure है, procedure is same, but here only if you see this example, this is same example 6 तक. Now let's see this example. ये आपको कौन सा इक्वेशन नजर आ रहे हैं? ये कौन सा इक्वेशन है? This is example 7.
Okay, sir.
नॉन होमोजीनियस डिफरेंशियल इक्वेशन
Non-homogeneous.
नहीं, और सर ये वो भी काशी
Yes,
Euler equation.
Cauchy-Euler equation. So you will not write the characteristic equation, you will write the auxiliary equation. So what will be its auxiliary equation? If you remember, am
Sir.
square plus b minus am.
For that is no.
Yes,
Remember?
sir. Plus c is equal to 0.
Plus c is equal to 0. Am square, a is 1. So this will become m square plus b is minus 3. b minus a. So minus 3.
4
Minus 3 minus 1. So this will become
minus 4m.
m square minus 4m plus 3 equal to 0. Okay?
Yes, sir.
Okay, G. So you will get two values of m. What is one? One is 1 and another is 3. So what will be yc? Yc will be this one now. C1x power 1 and C2x power 3. So what is your y1? What is your y1? Y1 is x. What is your y2? Y2 is x cube. So the remaining procedure is same. Remaining procedure is same. This is w. This is x into this is y1. This is y2. Y1 and y2. This is x cube. Y1 is x. Y2 is x cube. So you write it y1, y2, y1 dash, y2 dash, this is 2x cube. This is 0, this is f of x, this is y2, y2 dash. So remaining procedure is same. Is it okay?
Yes, sir.
Okay. So higher order को छोड़ दे क्योंकि ये फिर 3 cross 3 में चला जाएगा and the question will become lengthy. So इसको छोड़ दे higher order. So now this is linear models, that is initial value problem. So we are now solving a practical problem. We are developing a differential equation and then we will try to solve this differential equation. So let's see, this is an example, this one. Let's see figure 1. In subfigure 1, in subfigure A, if you see, this is a spring and this is unstretched spring whose length is L. L is the length of this spring. This spring is unstretched. If you attached a mass M with that spring which is shown in subfigure B, so its length increases and it become L plus S. समझ आ रहे हैं?
Yes, sir.
Okay, Ji. Why
Yes, sir.
why its length increases? कोई
Due
बता
to weight. Due to weight.
due to force. Yes, and weight is the force in this case. So it displaces, the spring displaces its points due to weight, due to gravitational force. So always remember that if there is a force, so there will be an opposite force that will resist that force according to the third law of motion, and the magnitude will be same but direction will be opposite.
Hooke
ठीक है जी? So if there is a weight force that acts downward, so there will be another force due to spring elasticity. समझ आ रहा है? जी
रिस्टोरिंग फोर्स होगी।
हर फोर्स का एक रिएक्शन फोर्स होता है ना. देयर इज ए व्हेन देयर इज ए फोर्स देयर विल बी एन अपोजिट फोर्स. Suppose if you attached a mass of 2 gram with a spring, but the spring doesn't change its position. So it means we are applying some force on that spring, but it doesn't change its position. Why? Because there is also internal force inside the spring. But if you attached a 10 kilogram mass, suppose, now it displaces its position. It means now the weight force, that is the gravitational force, is greater than the spring inside, the force inside the spring. जी मुझे बता दे.
क्या सर?
अगर आप किसी स्प्रिंग के साथ मास अटैच करें, 2 किलोग्राम मास अटैच करें, सपोज वो अपनी जगह पे मौजूद है, स्प्रिंग अपनी जगह डिस्प्लेस नहीं कर रहा, इट मींस कि स्प्रिंग के अंदर जो अपना फोर्स है वो उस मास के फोर्स से ज्यादा है, इसलिए वो डिस्प्लेस नहीं हो रहा ना.
यस सर.
So there is always an internal force inside the spring. But if you attach 10 kg mass, so maybe the spring changes its position. It means now the gravitational force is greater than the internal force of the spring. ये clear हुआ?
यस सर, क्लियर है.
Okay. So if the spring, if the body is in equilibrium position, if the body is in equilibrium position, so the internal force inside the spring will balance the gravitational force. ये समझ में आ रहा है?
यस सर.
So this must be zero. mg direction is in downward direction, but ks is in upward direction. Ks trying to take this body upward, and mg trying to take it downward. If it is at the mean position, so it means that these two forces balances each other. So mg minus ks is zero when it is at equilibrium position. Okay, G?
यस सर.
Okay, G. Now let's see. This is the Newton law. At the right hand side, what is this? What is this? This one. This is force. MA. What is A? D square x by dt square. Clear हुआ? But force is equal to, there are two forces, gravitational force and this internal spring force. So the sum of these forces create acceleration. ये तो समझ में आना चाहिए, ये तो सिंपल है.
हाँ आ रहा है सर, आप आगे चले.
If you multiply k with s, k with x, so you will get minus kx, mg minus ks is, so mg minus ks is equal to 0 when it is at the equilibrium point. So this will become m d square x by dt square is equal to minus kx. So this is your equation. So remember this point. When a body is attached with a spring, when a body is attached with a spring, so its equation is what? Remember this point. When a body is attached with a spring, if there is no external force, so this will be equal to what? This will be equal to, we can write it in this way. That is m d square x, m d square x by dt square equal to minus kx. So this is equation of a spring of a mass attached to the spring. This is x. What is x? X is displacement. X is displacement. Now, if you write it in this way, d square x by dt square, this is equal to minus k over m. X, this is equal to 0. Sorry, this is this one. If you take the omega square is equal to k over m, so you will get what? If you take omega square is equal to k over m, if you substitute omega square is equal to k over m, so what will it will become? Because m is constant and k is constant, so this must be square. Square means positive. M is positive, k is positive, so it means omega, we can write this value in the form of square. ये समझ में आ रहा है ना ओमेगा स्क्वायर क्यों ले रहे हैं? You can take any number 2 in the form of square, that is square root 2 into square. But if this number is positive, so you can perform this calculation. ये clear है? Any number,
एंगुलर वेलोसिटी है ये ओमेगा
any number, suppose this is 3, if this is positive, so you can write it square root 3 into square, but the question is if it is positive. So every number, if it is positive, you can write it in square. So what is k? K is the elasticity, it must be positive. Maybe it is 0. And gases, there is no elasticity. Okay? So because there is no internal, the internal forces tends to 0 in gases. So the k is 0. So k may be 0 in some material, but k may be positive. K will never negative, and mass is also negative. Positive always. So if you divide the two positive values, so it will become positive. So it means that you can take it omega square. So this will become d square x by dt square. This is equal to omega square. Also, this will become minus omega square because negative is already with this. So, if you write the characteristic equation, this is omega square x. So this will become m square equal to minus omega square. This is the characteristic equation. So what is m? So m is plus minus iota omega. This is plus minus iota omega. This is the characteristic equation. So if you take m is equal to plus minus iota omega, so what will be the general solution of this? So the general solution will be this one, c1 cos omega t plus c2 sin omega t. ये क्लियर हुआ जी? देख ले, अगर ओमेगा if m is iota omega, so what will be solution? Now this is x, because now the dependent variable is x and dependent is t. So now xc will be equal to what? E power alpha is 0 in this case. E power 0 t is 1. So c1 cos of omega. Now the independent variable is time. So omega t and plus c2 sin omega t. So this will become your solution. So already यहाँ पे हैं c1 and c2. So this one. Now this is an example. Example 1. So let's see this example. A mass 2 pounds stretches a spring 6 inches. Question थोड़ा सा सुन ले. This is a question. G. Question is, this is a spring. This is a spring. ठीक है जी. This is a spring. The length of the spring is 6 inches. So if you attached a mass with it, after this it become 8 inches. So this is suppose now new length of this become 8 inches. After attached of mass, it become 8 inches. Is it clear?
Yes, sir.
Okay, ji. So what is 6 inch converted into feet? This will become 1 or 2. At 8 inch, this will become 2 or 3 feet. What is mass? Mass is actually equal to weight by W is equal to mg. So m will become W by g. What is m? M is 2. What is g? G 32 meter 32 feet per second square के equal नहीं है 32 feet. G किसके इक्वल है 9.8 मीटर पर सेकंड स्क्वायर, बट इन फीट दिस इज 32 फीट पर सेकंड स्क्वायर. जी क्यों आप सारे सो गए?
No, sir.
32 फीट पर सेकंड स्क्वायर नहीं है जी.
Yes, sir.
Yes, sir. 9.8, 32 feet per square.
Yes, so 2 divided by 32 is 1 over 16. तो m is 1 over 16. नोट करें इसको. अब मुझे स्प्रिंग के स्प्रिंग का इक्वेशन किसके इक्वल है? स्प्रिंग का इक्वेशन इसके इक्वल है. रिमेंबर दिस पॉइंट. m d square x by dt square is equal to minus kx. So we need m. M is what? M is w by g. So if m is if weight is 2 and g is 32, so it means the w will become 1 over 16. So this m is now 1 over 16. This m is 1 over 16. Now what is this k? आपने Hooke's law पढ़ा है? In Hooke's law, f is equal to kx, if you remember. According to Hooke's law, f is equal to kx. So according to Hooke's law, what is f? In this case, f is actually weight. So weight is 2. So 2 is equal to g. What is x? X is the increase in length. Increase in length कितना हुआ है? स्प्रिंग कितना इंक्रीज हुआ है?
2 inches.
2 inches. 2 inches को फीट में कन्वर्ट करें. तो 1/2 बन जाएगा. ठीक है जी. या आप इस तरह करें कि 1 over 2 फीट से 2 और 3 फीट से 1 over 2 माइनस करें. यू विल गेट 1 over 2. ये क्लियर हुआ ना?
Yes, sir.
ओके जी. सो यहां से आपको k की वैल्यू मिल जाएगी 4. सो if the value of k is 4, so you put it here, that is this one. You will get 1 over 16 d square x by dt square is equal to minus 4x. So you will get this one. This is the equation of spring now. D square x by dt square plus 64x, because if you multiply 16, you will get this one. Now this is homogeneous or non-homogeneous?
Homogeneous.
Okay, Ji. So what will be its characteristic equation?
Sir, m square minus 60 minus plus 64m equal to 0.
Yes. So m क्या होगा?
M is equal to minus 8.
Plus minus 8 iota.
Yes, sir. Plus minus. Yes, sir. Plus minus 8 iota.
So this will become xt will become c1 cos of 8t plus c2 sin of 8t. ये clear है यहाँ तक?
Clear है सर.
अच्छा जी. अब c1 c2 कैसे फाइंड करें? क्वेश्चन में थोड़ा सा देख ले, हाउ टू फाइंड दिस C1 and C2. At t is equal to 0, this is initial condition now. The mass is released from 8 inches. The mass is released from 8 inches. Remember this point. So at t is equal to 0, what is your x? Because this differential is dependent on x. So what is x when t is equal to 0? When t is equal to 0, x is 8. 8 means 2 or 3 feet. When time was 0, so the distance is 8 inches. So the length is 8 inches. 8 means 2 or 3 feet. So 8x is equal to 0 when time was 0. When time was 0, so what was x? What is the value of x? 2 or 3? ये क्लियर है?
सर ये रिपीट कर दे।
अच्छा जी, देखिए, this differential equation is now dependent on what? पहले आप मुझे ये बता दें, it depends on x. It depends on G.
X.
It depends on x. So to solve this differential equation, you need two initial condition, because this is the x depends on time. X depends on time. So you need two initial conditions. Now, when at t is equal to 0, 8t is equal to 0, 8t is equal to 0, what is the length? The value of x is 8. What is x? X is 8. At t is equal to 0, देखिए, this is the original length. This is original length. After a test of mass, this become 8 inches. Now, when the experiment started, so the mass is here. The spring is here. When the experiment start, so its length is 8. So it is released from this position. समझ आ रहे? As experiment started, it is at the position 8 length. So at x when time is 0, x when time is 0, so the value of x is what? The value of x is 8 inches. 8 inches means this is 2 or 3 feet. Clear? Is it clear?
Yes, sir.
Okay, Ji. So next we also need another condition. Another condition is the velocity is the question, and the question velocity is 4 over 3. It is given in question. It is given in question that velocity is, if you see, the upward velocity at time t is equal to 0 is 4 over 3. So what is meant by upward velocity? Upward velocity means the value of velocity will be negative.
Negative.
Yes, it is against. So what is velocity? Velocity means derivative of x. At time t is equal to 0, the velocity is minus 4 by 3. So one condition is this one, another is this one. So use these two conditions and find the value of C1 and C2. Up to clear one.
Clear, sir.
Okay. Now this is free damped motion. This is another example theory. This is d square x by dt square. At the left hand side there are forces. This is spring constant, and what is this? This is minus beta dx by dt, where beta is positive damping constant. So if you convert it, if you divide it by m, this will become minus k by m x minus beta by m into dx by dt. So if you take beta by m is equal to 2 lambda and omega square is equal to k by m, and you put the values, so you will get m1 is equal to minus lambda plus lambda square plus omega, and this one. So this will become the solution. If you see, this is simple. Now, there is no need of cases. This is an example. What will be its solution? What is the characteristic equation of this equation? M square,
Plus 5m
yes,
plus 4
2.
equal to 0.
So if you solve this, you will get C1 e power minus t plus T2 e power minus 4t. So if you apply these two conditions, you will get C1 is 5 by 3 and C2 is minus 2 by 3. So this is another example. A mass of 8 pound stretches a spring 2 feet. So stretch कितना stretch कर रहे हैं spring को?
2 feet.
2 feet. So remember, in Hooke's law kx, so the value of x is 2 because it's stretches at 2 feet. So directly the value of x is 2. So f means weight. This is 8. So f is equal to 8 is equal to kx means 2k. So k value is 4. ये clear हुआ ना?
Yes, sir.
Clear.
Yes, sir.
So what is m? M is w by g. If weight is 8 or g is 32 feet per second square, so this will become 1 over 4. So mass is 1 over 4. So remember this equation. Remember this equation. This is this one. Mv square x by dt square equal to minus kx minus beta dx by dt. So putting the values in this equation, you will get this one 1 over 4 d square x by dt square minus 4 and this one. So you will get this equation d square x by dt square plus 8 dx by dt plus 16x is equal to 0. So if you write the characteristic equation, it will become y double dash m square plus 8m plus 16 equal to 0. So if you solve this equation, you will get same values of m minus 4 and minus 4. So if you write the solution, this will become C1 e power minus 4t and C2 t e power minus 4t. So if the initial condition is this one, because it is given in question, that velocity is 3, upward velocity is 3. So it means this is minus 3. So this is same one. This is example 5 of same. So this is example 6. Now इसको छोड़ दें. This is example 6. चले 8 छोड़ दें. RLC सर्किट छोड़ दें, ये इलेक्ट्रिकल के लिए है. So example 68 पेज तक कर ले. Sorry 60 ये है 65 तक. 65 तक कर ले. फिर यहाँ पे थोड़ा सा आ जाए डिफ्लेक्शन ऑफ बीम. ठीक है जी. फिर 73 पेज पे आ जाए. सो 65 से लेके 72 पेजेस तक जो स्लाइड्स हैं वो आप छोड़ दें, वो इलेक्ट्रिकल में यूज होते हैं. तो आप अपने प्रॉब्लम पे आ जाए डिफ्लेक्शन ऑफ ए बीम. ठीक है जी. डिफ्लेक्शन ऑफ ए बीम. आप थोड़ा सा यहाँ पे देख ले, बीम की थोड़ी सी अकसाम देख ले. There are 3 types of beams. One is the beam in which it is fixed from 2 ends. ठीक है जी. This is a beam which is fixed at 2 ends. One end is at x is equal to 0, another is at x is equal to L. This is another one which is fixed from one side and it is free on other end. It means वो जमीन पे है एक end उसका and second end is fixed with some position and with x is equal to 0. Is it clear?
Clear.
Okay ji. And the third one is when the two ends are on some support. X with some support. ठीक है जी? So this is three types. So let's see. What is m d square x d square m by dx square? What is d square m by dx square? Remember that m is the bending moment. Bending moment. आप जितना लोड अप्लाई करेंगे किसी बीम पे तो उसका बेंड जो होगा मोमेंट वो बढ़ेगा ना. ये देखें, दिस इज ए बीम. ठीक है जी? Suppose this is a beam. If you apply some load on this beam, this is a load. So it maybe it become in this way. Okay ji?
Yes, sir.
So the bend moment m is what? The moment of the bending. इस फॉर्म से ये इस फॉर्म में कन्वर्ट हुआ. इसके यहाँ पे इसका बेंड कितना था? इस स्ट्रेट लाइन फॉर्म में the bending was 0. If it is a straight form, so there is no bending. Okay?
Yes, sir.
Okay.
Yes, sir.
Okay जी. So if it is now in this way after applying some load, so it means के bend जो है वो थोड़ा सा move हुआ एक जगह से दूसरी जगह पे. This is called moment, bend moment. So bend moment as the change in bend moment is actually equal to the weight on this beam. W is weight actually. Clear हुआ? Is that clear?
ये बेंडिंग के लिए सर हम डबल डेरिवेटिव क्यों ले रहे हैं?
हाँ, yes. This is actually acceleration.
ओके सर.
Okay. So now let's see what is W. W maybe W is variable function and maybe W is constant. If you distribute the weight on this beam equally, so it means the W is constant at all points of the beam. Okay? Is it okay? If this
Yes, sir.
If this W is constant, it means that the load is distributed equally along the length of the beam. But if Wx is variable, it means that the load is distributed differently at different value of x. At different length of x, its load is different. Is it okay?
Yes, sir. Yes, sir.
Okay.
सर ये बेंडिंग में भी एक्सेलरेटेड वैल्यू ली जाती है सर?
बेंडिंग में आप ले सकते हैं ना, वेरिएबल वैल्यू भी ले सकते हैं, लोड एंड यू कैन आल्सो टेक कांस्टेंट वैल्यू. अगर पुल पे गाड़ी गुजर रही है तो कभी वो एक जगह पे लोड कुछ और होगा, दूसरी जगह पे कुछ और होगा. सो अलोंग द पुल लेंथ जैसे आप मूव करेंगे लोड विल बी डिफरेंट. ठीक है जी?
ओके सर.
बहरहाल when you construct a beam, so you are trying to apply a uniform load, a constant load at each position. So what will be its behavior? आप तो ये ट्राई करेंगे ना, अगर किसी बीम पे सेम टाइम्स पे हर जगह पे इक्वल फोर्स आ जाए कितना बोझ आ जाए ताकि वो बर्दाश्त कर सके. So you are constructing at this level. Okay.
Okay, sir.
Okay, ji. So now what is M? M is actually
Bending.
proportional to curvature. What is curvature? What is curvature? आपने curvature कैलकुलस में पढ़ा है? कर्वेचर कैलकुलस में पढ़ा है?
No, sir. No, sir. No, sir. No, sir.
अच्छा जी, थोड़ा सा मैं एक्सप्लेन कर लेता हूँ. ज़्यादा डिटेल में तो हम नहीं जा सकते. आपको असल में कैलकुलस पहला सेमेस्टर में पढ़ाया जाता है, तो ये मेहनत पर हमें नहीं करनी पड़ती. एफ यू सी, मुझे आप ये बता दें कि ये एक ग्राफ है. इसमें dy by dx पॉजिटिव होगा या नेगेटिव होगा?
पॉजिटिव होगा.
When you are moving from this point towards upward, तो डेरिवेटिव पॉजिटिव होगा.
पॉजिटिव
sir.
होगा सर.
Yes, sir.
क्यों पॉजिटिव होगा?
सर ये मैक्सिमम वैल्यू हमारे पास आ रही है ऊपर.
हाँ, मतलब डेरिवेटिव
सर ये ग्राफ इंक्रीज हो रहा है सर. ये चेंज ऊपर जो है ये इंक्रीज हो रहा है ना सर. इसमें चेंज आ रहा है.
what is mathematical reason behind this? If you take derivative, so derivative is equal to y2 minus y1 divided by x2 minus x1. This is derivative. So if you are, suppose if you are at this point, suppose, so at this point this is your value of y1 at point x1, and now at this point this is your y2, and this is at x2, this is the value of y2. So if you are moving from y1 to y2, so y2 minus y1 will be positive. It will be positive value because y2 is greater than y1. x2 minus x1 is always positive. This is always positive. So if you divide positive value by positive value, so it means if you are moving from here to here, so the derivative will be positive. Is it clear now?
Clear.
If you are moving from upper to lower, so again, now this is your x1, suppose. So this is your y1, this is your x2, suppose, and this is your y1, y2. So now x2 minus x1 is always positive. Now y2 minus y1 is negative. Okay?
Yes, sir.
So derivative is negative. Derivative is less than 0. This is less than 0. So now let's see. If you are moving on a straight line, so derivative increases or decreases? Now I am talking about the increase of derivative, not about the function.
सर स्ट्रेट लाइन पर हमारे पास रेट ऑफ चेंज कांस्टेंट नहीं होगी. डेरिवेटिव हमारे पास रेट ऑफ चेंज होता है ना.
मुझे आप सिर्फ ये बता दें, इस टेंजेंट का स्लोप, इसमें से सबका ज्यादा स्लोप किसका? ये डबल आवाज आ रही है. जी, हेलो.
यस सर.
अच्छा जी. इसमें इसका स्लोप ज्यादा होगा ये
पहले वाले पे ज्यादा होगा ना सर.
पहले वाले का. ठीक है जी। सो स्लोप डिक्रीज हो रहा है ना।
यस सर, डिक्रीज हो रहा है।
सो दिस इज कॉल्ड कनकेव डाउन। क्लियर हुआ? So the double derivative actually shows you the bending. Suppose if you take a straight line, so the tangent at this point, this is one point, this is another point, suppose this is another point, this is another point. So what will be its tangent at this point? This one. What will be its tangent at this point? This one. Tangent at this point will be this one. Tangent at this point will be this one. So as the tangent doesn't change the direction, so let's see. Tangent means first derivative. Doesn't change means double derivative. So double derivative will be zero. थोड़ी सी मेरी बात को सुन ले, जीरो होगा ना, because tangent doesn't change its direction. Tangent means first derivative. Clear? Tangent doesn't change. Change represents the second derivative. Doesn't change means zero. Is that clear? G.
Yes, sir. Yes, sir.
Okay, G. So the double derivative, if you are moving on a straight line, so the curvature of that straight line is zero, because the double derivative gives you the curvature of that curve. Okay. So M is actually proportional to the curvature. EI is the constant. It depends on material constant. So what is K? K is actually curvature, and curvature is approximately equal to double derivative. Curvature is double derivative of Y. So if you replace this M by double derivative, so already M पे double derivative पहले से भी है, so it become fourth derivative. So now this equation is actually G. थोड़ा सा 10 मिनट और
बस ठीक है सर, वो वहाँ पे लैब में बैठी थी सर। असल में सर उसकी आज पीजी का एडमिशन है।
अच्छा अच्छा,
आपसे कंसल्ट किया था उन्होंने।
हाँ ठीक है ठीक है।
और सर मैं वो मेरे वाइफ है सर।
अच्छा अच्छा
मेरे मिसेस को भी सर।
अच्छा, मेरा भी क्लास शुरू है।
ठीक है सर, बस सर वो मैं आपको तो 10 मिनट बाद।
ठीक है। So now this become a fourth order differential equation. So now the procedure is how to solve this and the remaining things. So now let's see, this is an example. A beam of length L is embedded at both ends. It is fixed from both ends. Find the deflection of the beam if a constant load W0 is uniformly distributed along its length, that is, if Wx is equal to W0. So the differential equation is now EI d power 4y dx4 is equal to W0. So if you take the characteristic equation, so what will be the characteristic equation of this? You will make it homogeneous.
M power 4 is equal to 0.
Yes. So you will get YC will become C1 plus C2x plus C3x square plus C4x cube.
और सर ये EI क्या है?
ये कांस्टेंट है। ये हमने जब m की वैल्यू निकाली थी, so m is proportional to the curvature. जितना m ज्यादा होगा, m means movement, so जितना curved होगा वो बीम जो है, इतना उसमें मोमेंट होगा ना। So EI are the constants. So if you put these values, you will get the, what is YP in this case? YP will be A if you are solving it by undetermined coefficient method. Okay?
Okay, sir.
So if you take YP is equal to A, so actually A present in YC, so you will replace your YP by AX, but again at present in YC, so you will replace it by AX square. It is again present, so your last YP is AX power 4. So if you calculate A, so this will become omega naught 24 EI. ये क्लियर है ना, सिंपल है. Is it clear? What will be your YP? If you are using the undetermined coefficient method. Let's see, at the right hand side there is only constant value. So your YP will be A. But A is present in YC in the form of C1. So your new selection is AX. But AX is again present in YC in the form of C2X. So your new selection will be AX square. So it is again present. So the last selection is AX power 4. Then you differentiate this YP 4 times in the given differential equation, and you will get A, and you put it in YP, and the A value will be omega naught 24 EI. Is it clear now? G.
No, sir.
Okay, G. So this is the solution. Now this is the graph. So if you see the graph at two ends, you can plot this function, that is yx, on graph by putting values. If you put L is equal to 1 and omega naught is equal to E 24 EI, so you will get this graph. This is the graph. So if length is 1, so you see that as you are moving away from ends, so it bends increases. So it means that at the center, as you are moving away from the support, so the bending of the beam increases. So actually you need to fix it also from center. So you need to give support at the center to avoid this bending. Okay.
Yes, sir.
So as you are moving from ends, that is from fixed points where these two ends are fixed. So as you are moving away from these fixed points, so the bending, yeah, the curvature of the beam increases. So you can see that. Now it depends on length. If L is 2, so the bending will increase more and more at the center. If L is 4, L means 4 meter, 4 centimeter, 4 kilometer. So as you increase the length, so the bending will also increases if you graph the graph. So this is your class work, and I will put your homework also related to this method. So let's see, आपका नेक्स्ट वीक में एग्जाम है. कल आप लोगों का 6 बजे क्विज होगा. मैंने आपको मैसेज किया था. ठीक है जी.
सर एमसीक्यूज में ऑप्शन होंगे सर?
एमसीक्यूज में ऑप्शन. ठीक है जी.
सर ये कितने टाइम
जी
पेट निकल गया जरा ले दे.
आधे घंटे का होगा.
एमसीक्यूज टाइप हो गए सर ना?
जी एमसीक्यूज टाइप होगा। ठीक है जी।
सर ये क्वेश्चन सॉल्व करनी होंगी या बस छोटे छोटे एमसीक्यूज होंगे, बस उनका डायरेक्ट आंसर लिखना होगा?
सॉल्व करने होंगे तो तब फिर आप आंसर देंगे।
तो फिर
बस
कितने
सर ऑप्शन
एमसीक्यूज
तो
होंगे?
होंगे ना सर?
ऑप्शन होंगे ना, ऑप्शन होंगे, 4 ऑप्शन होंगे। डिपेंड करता है आपके जहन पे। कोई जहन ऐसा होगा कि वो डायरेक्टली देख के बता सकेगा, किसी को सॉल्व करना पड़ेगा।
कितने एमसीक्यूज होंगे
यस
सर?
सर।
देखते हैं 5-6 तक मैं दे दूंगा। ओके, तो अभी मेरा 10 बजे मीटिंग है, 5 मिनट्स रहते हैं। सो ट्राई examples and homework for final term examination. Your paper will be open book paper. So half paper will be open book, and I think half paper is Viva or some like of objective. So I am not clear about this, so I want to clear, so I will inform you. Okay, Ji?
सर हम
Okay,
भी कर
sir.
लें?